Hello, everyone, and welcome to the ABB Process Automation Podcast. Metals are the foundation of a modern society. They are the key to construction, transportation, infrastructure, and technological advancement. From steel to copper to aluminium, these critical materials are indispensable to daily life and the global economy. The metals and mining sector amount to $4 trillion industry, around 35% of which comes from steel alone. According to the latest numbers for world steel, globally, over 200 kilograms of steel is used per person annually for new products such as vehicles, construction materials, household appliances, tools, and even food packaging, such as cans. Now, this demand is projected to grow even further. But to support an ever-growing society that will continue to thrive for generations to come, metals must be sourced and produced responsibly. For instance, the steel industry today is responsible for 7 to 9% of global CO2 emissions, and this means we need to focus on increasing the efficiency of how metals are sourced and produced while also meeting the growing demand. How on earth do we do that? This is exactly what we are going to explore in today's episode as we look at the future of the metals industry, as we ask the question, what can be done to create a more efficient and sustainable metals industry in order to responsibly meet the increased demand? I am Fran Scott, and this is the Process Automation Podcast from ABB. We are going to be joined by Frederik Esterhuizen, the Metals Business Line Manager at ABB, and Rajesh Nair, CEO, Tata Steel UK. But first, I am delighted to welcome Helena Malmqvist, the Research Manager at Jernkontoret, who started by setting the scene of the metals industry.
So this is a very, very old industry, and we could produce iron several thousands of years ago. But the main breakthrough for iron production was when we started using blast furnaces, which was already in the 12th century in Sweden. And in a blast furnace, you reduce iron ore with coke to produce iron. And this is actually still the main process for steel production or iron production. And the steel industry was also very early to understand the importance of recycling. And we started using electrical arc furnaces to remelt scrap more than 100 years ago. So today, we're mainly producing steel from iron ore. 2/3 is produced from that, and 1/3 is from remelted scrap.
Oh gosh, I didn't realise that we'd been using electric arc furnaces for that long. I naively thought that, I don't know, we'd been using them for just a few past decades. So we've been doing things well for quite a long time, haven't we?
Yes, we have. And of course, we started using electrical arc furnaces because it's much easier to remelt steel than producing it from iron ore. So that was a smart invention.
Absolutely. And how do you think the metals industry will continue to change and grow into the future?
Well, if we look back, the global production of crude steel has doubled since the year 2000. And we actually foresee a huge increase in the future too. And that's in figures like an increase of about 30% the next coming 25 years. And I mean, steel is used in a lot of constructions, like in houses and bridges and cars and all that comes with a growing population. But also steel will be very important for the energy transition. It will be used in solar panels, in electrical vehicles, and so on. So unfortunately, producing steel causes large CO2 emissions, and especially if we produce it from iron ore. And that will be the case as long as we think that we will have an increase in demand. So there will be a huge need to make this growth with a less impact on the environment than before.
So how is the industry doing this? We all know that making metals, it is an energy intensive process and it creates lots of emissions. And so how is the industry addressing these challenges? And in particularly when we look at steel production?
You're right about that. The steel industry are causing about 8% of all the CO2 emissions globally. And this is, of course, not acceptable. And this is something we need to address. So right now, techniques are being developed to use hydrogen instead of coke to reduce iron ore to iron. And this is actually very clever because if you use coke, you will produce CO2. But if you use hydrogen, you will produce water as a byproduct. And that is, of course, much more environmentally friendly. And since this step in the production causes about 85% of all the emissions, this is, of course, a major impact. And there are also other parts in the steel production that causes CO2 emissions. And therefore, we're looking into like biocoke, biogas, and also to electrify the processes where it's applicable. So that is on like the production side that we need to reduce our impact. But it's also very, very important to take into account how the end product is used. So if we produce materials and produce steels with much better properties, and if it's stronger, more corrosion resistant, more wear resistant, then this lifespan will be much longer and we will have to use much less materials. So that will also have a huge impact on the environment.
Understood. And so when we look at steelmaking processes, how do you go about optimizing these through an environmental lens?
Yeah, we can see that a lot of industries have started to making changes in their production. It's like electrifying the furnaces if they can. And what we can see is that when you make these same changes, the next step is always optimization. And in a steel plant, it produces a lot of data. And if you start using like smart sensors, big data analytics in combination with machine learning, you can improve both the production and the product quality and thereby reduce losses. So we see a lot of work in this area right now.
Oh gosh, so there's so many different areas that need to be addressed. I suppose so many different aspects of industry and industries that need to work together hand in hand. It's not just a case of the steel industry going, "Hey, we'd like to do this." It needs changes, I suppose, worldwide, doesn't it?
Yes, and also along the value chain. I mean, from the iron ore to the steel manufacturers to the car producers or whatever, and then finally ends up with us as the customers. So it has to go all the way. And it's also very important, like, how is the government acting? How will we get access to this energy? How will we get access to this competence? How will the whole setting be prepared for this to happen?
So, Helena, if we look at the steel manufacturing process in, say, 40, 50 years' time, what will that industry look like? Will we still be burning things? Will everything be electric? Could you paint a picture for us of what it may look like?
I think we will have different solutions on this because if it's electric, you need to have CO2-free electricity. Otherwise, it's not worthwhile going into the electric path. And here in Sweden, we have that possibility. So here for Swedish steel companies, that is a solution. But in other countries, they don't have the same possibilities. So they might have to find other solutions. Maybe carbon capture or other solutions. I think we're all accepting that we cannot continue as we've done before, and especially with this huge increase we foresee in steel production over time, it has to become much more environmentally friendly. And we need to put a lot of energy on research to try and find out new ways and new paths for this.
Absolutely. And so I suppose it's that collaboration, isn't it, between research and industry. That's where the secret lies in being able to find a solution, or I suppose many solutions.
I think we'll see many solutions. And also this cooperation is extremely important that we work together because this is a problem for all steel companies worldwide.
But what's interesting is because we all use steel, I don't think it's just a problem for the steel industry. It's kind of a problem that's created by established humanity. And so, in a way, should we all be looking for a solution?
Yes, if you look around, you probably see a lot of metallic materials in your surrounding. And if it's not, it has probably been used metallic parts to produce what you have. So, I mean, it's everywhere. And we've taken it for granted for very many years.
But what is nice about this is because it's everywhere and because it's a growing industry, a surprisingly really growing industry, that means that if any change is made, then that change will really have an impact. And that is really inspiring.
It will definitely have an impact, yes.
Up next is Frederik Esterhuizen, the business line manager at ABB, who started by explaining where ABB sits within the metals value chain.
You need to start from the mining perspective where we mine the iron ore. Then you need to convert that from iron ore into steel with the different melting applications. From the melt shop, it actually goes into hot rolling mills, cold rolling mills, and profile mills, which then in the end of the day ends up with the products we use in our house and in the environment around. And ABB actually plays a key role in all of these areas. From the mining side, we are working with the hauling of electric trucks as an example. We've got the mine hoist applications in there. From a metals perspective, we also play a key part in the furnaces, the hot rolling, cold rolling, and the profiling mills, where we have various digital automation and electrification solutions where we can help our customers to really make their productions more energy efficient, more effective, and in that way also increase the production for them. So really helping them to outrun the industries and the applications they are working in.
One of the challenges that we hear about when it comes to the metal industry is that it's very energy intensive. And so what can this industry do about its carbon emissions? And in particular, what are ABB doing about that?
The CO2 emissions, the main contributor is really focusing on the furnace side of it, the melting process. Now, the melting process traditionally were done with a basic oxygen furnace, which relies on iron ore and coal to actually do the burning and then effectively coming out with your hot steel on the other side. Nowadays, there's quite a lot of changes, and you can use an electric arc furnace for that application.
Just out of curiosity, is there anything that your traditional blast furnace can do that an electric arc furnace can't? Or can it be a direct replacement?
It can be a direct replacement.
Absolutely, because there is this old-fashioned view, isn't there, that electric arc furnaces can't produce your high-grade steel. And that's how they used to be, but it's not how they are now.
That's correct. I mean, we have the advantages of digital and AI nowadays. So by making use of the scrap, we can actually separate the scrap into low grade and high grade. So by really getting the higher grade scrap into the melting of the EAF, you can really then get the higher quality product and the stronger product, if I can say that, out of the electric arc furnace.
Understood. So not only are you decarbonising the melting process by electrifying it, also by analysing the ingredients and the product at different scales to make that process as efficient as possible.
That's correct. And also, I mean, one of the products we actually sell from an ABB perspective is our electromagnetic stirrers. And the electromagnetic stirrer actually fits at the bottom of the furnace. And all we do, we actually, as it states, stir the metal. So you keep on mixing it and you ensure that the slag and stuff stay at the top. And actually, by using the stirring process, you are reducing the time of melting the product. So you get higher efficiency and higher production out of the furnace. So, and you also need lesser energy on it. So a lot of things contributing, which then also makes sense in getting you a better product in the end of the day out of the furnace itself.
Got you. So the electromagnetic stirrer, correct me if I'm wrong, I suppose it somehow sets up an electric current that then means that there's an opposing magnetic current that means that the whole melting pot of ingredients that go to make the steel are stirred, but they're stirred in such a way that they mix together much more thoroughly than they would without
That's
it.
correct, yes. So electric stirrer, as the name says, the magnetic field effectively starts stirring because it's steel or it's metal. So magnetic fields then help it to stir in the process. So really, actually, the magnetic stirrer was patented 80 years ago in Sweden. So it was really coming from our predecessors, ASEA, which were developing that in the industry.
It just seems that the devil is in the detail here. Like, this technology in many aspects has been around for decades, but now we've got the high tech, let's call it, where we can analyze things in a way that they need to be analyzed to get them as precise as we need, to get the savings that we need to make this old technology as efficient as we now need it to be.
That's correct. I mean, on the DRI side, as I said, we also make use of our APC, the Advanced Process Control, where we're trying to really optimize the entire flow. We also use the Advanced Process Control in other applications. So every little bit and little part of the entire value chain we look at and try and add, because unfortunately there is no new way of making steel yet. It's been done this way, as you mentioned, for decades, and it cannot, there is no way to change it. We are using electric arc furnace with different fuels, hydrogen. We also, with the electric arc furnace, we have the possibility, if you use hydrogen, to also look at the different melting temperatures and play around with that. We can make, a lot of customers are trying different applications with carbon capture as well, where you can get it. And also, which helps, but the challenge as well from a metal side is you've got so many places in the value chain where there are emissions. You can't just focus on the one. So if you focus on the one, yes, it will bring, like on the furnace, it will bring you good savings. But also downstream, you need to look at all of that to be able to really, at the end of the day, come to a fossil-free or fossil-neutral steel application out there. So you need to take a look at each and every part of the process.
So, Fred, are you optimistic about the future of a sustainable metal industry? Can it happen?
Yes, I'm very optimistic around it. It will not happen in 1 or 2 days. That's unfortunately the reality of the industry. I think what is also important for us to understand, steel or metals are in our daily life. If you just look, a couple of years ago, I had issues, so I've got a steel knee. It's coming from the steel industry. If you look at our buildings out there, all the buildings are reinforced with rods because that's the way what gives it the flexibility and the strength. So your iPhone, your fridge, as I mentioned, all of those things are really a key part of our lives going forward. And also, if you look at we keep on growing in the world. So you need to build more buildings. You need to be more efficient. If you also look at it, we want to improve sustainability, so we need to look at the electrification side of things. You need steel in your transformers, in your electrification, in your panels being used for electrifying the future. All of that needs steel in an extent. And also from a legislative perspective, all the different governments and so forth are really bringing in legislation to make sure our suppliers, our customers, and our manufacturers are really making use and really driving the sustainability targets. So I think combining technology changes, there's a lot of new things happening. We hope there would be some breakthrough as well in the near future, but it is an industry which are there to stay. There's going to be a lot of possibilities to improve it. And until such time that is a complete new technology, there's a lot of things we can still do to continue down this path of reducing CO2 emissions.
Thank you so much, Frederik. And our final guest today is none other than Rajesh Nair, CEO of Tata Steel UK. So to start with, Rajesh, in your annual report, it states that Tata Steel intends to achieve net zero emissions by 2045. Could you please just walk us through some of the key actions and the key strategies that the company is putting in place in the UK so it can achieve this goal?
Yes, indeed, Fran. That's our stated position as far as not just the company, Tata Steel as a company, but it's also the position that Tata Group as the larger holding group has made to itself and to its stakeholders in terms of where it would like to go. And specifically for Tata Steel UK, we are already on that progression or on that roadmap. The most important thing that we are doing just now is pivoting from our blast furnace and oxygen steel making, which is or the integrated steel making route to an EAF process that we have announced, and it will substantially reduce our CO2 footprint from the current levels of around between 6 to 6.5 million tons, which is what we were emitting when we were operating at 3 million tons. By this single change, by the end of 2027, we are looking to reduce something like 5 million tons of CO2 on the Port Talbot site. So effectively, on our steel making site, we will be reducing our CO2 by nearly 90%. But as a company, because we also have downstream, which has got its own carbon density. So from a scope 1 perspective, we will still, at a company level, at a corporate level, we would be at a level between 50 to 60% of our current footprint. So that's what we are aiming to achieve in the next 2 years. Then through to 2045, we have different plans to further eliminate CO2, especially in our downstream operations, through a mix of technologies and approaches, which will involve transitioning from gas to electricity, which will involve looking at potential uses of carbon capture and storage, etc., to eliminate the remaining carbon that we have as far as our scope 1 and scope 2 are concerned. And then we will continue to work to reduce our scope 3 emissions, where we will have to work with our supplier partners and other stakeholder partners. But we're well on our way in the UK to get to our net zero targets by 2045.
Understood. And scope 1 being emissions that you directly happen within the company, and scope 2 being emissions that you from other companies that you use, so kind of emissions from the energy that you use within what you do. That's correct, isn't it?
Absolutely right.
So talking about electric arc furnaces, so the EAFs, now I know that they are expected to play a crucial role in the future of the steel industry. But what are their benefits, and how is Tata Steel integrating these technologies into its operations?
So the electric arc furnace route, the route that we have taken, which is primarily scrap-based EAF, eliminates completely the need for making iron in the first place. So if you were to compare our past footprint, where we had the coke ovens and the blast furnaces and the sinter plant and the steel shop, all those assets to first take the iron ore and coal to convert it into liquid iron and then convert it into steel. Now, we're replacing all that with an asset which will just heat the scrap and convert it into steel directly. So in a sense, we have taken away a whole lot of assets that were required to produce the same amount of steel with far smaller assets. So it's a significant improvement in all kinds of efficiencies, material efficiencies, asset efficiencies, capital efficiencies, maintenance efficiencies, energy efficiencies, etc. So straight away, we are getting into a completely different paradigm of making steel. It's not a new paradigm, but for the UK in flat steel, it's a completely different paradigm. Then in terms of the footprint, which then goes to the point around how you minimize the impact on the environment and the impact on the resources, having a smaller footprint, managing it smaller, makes you that much more efficient in terms of reducing your footprint and resource usage.
So when it comes to changes, automation is playing an increasingly important role in the steel industry, isn't it? So how is Tata Steel utilising automation to improve its production processes?
Yes, indeed. Automation will be a key enabler to future success. And, in fact, one of the challenges we have thrown to ABB and Klesim, who is our partner in the new project that we are doing, is to challenge ABB also to say, okay, let's come up with, based on what ABB has been doing in the field of automation, what's the art of the possible for this new investment that we are doing? Okay, so some of these challenges have been thrown back to them to say, okay, how do we make it, let's say, a lighthouse piece as far as automation is concerned? Now, having said that, like in everything, automation helps us to address a number of issues. First and foremost, I think our ability to automate and use automation in the right way goes a long way in ensuring safety and health. In the new world, we owe it to our people to make all our sites and all our assets as safe as possible. And automation very eminently helps us to do that. The second area where automation can really help is in trying to improve efficiencies and all kinds of efficiencies. It can help make the systems and processes more reliable. It can make the equipment more reliable. You can use automation to help improve efficiencies of maintenance. You can help it improve efficiencies of material utilization. And then as you go down the value chain, every place automation can help us improve, bring about efficiencies, efficacy, and making sure that ultimately when we get down to the customer, we are able to deliver the right product at the right price and at the right value. Automation is going to be key to future success, and our ability to actually think creatively and to constantly look at the new art of the possible will be the driver. It will not be the technology. It will be our ability to think and our ability to envision the art of the possible is what is going to limit us in terms of using automation.
Makes total sense. And gosh, so it seems like Tata Steel is not only changing, but it's embracing this change. And so looking ahead, how do you see the future of the steel industry evolving over the next, say, decade?
The biggest challenge for steel is the fact that it's a hard to abate sector, and therefore it has a high carbon footprint, and we need to find the solutions. And we think we have solutions as we move forward. I believe the steel industry is committed to making it happen. Different companies and different countries and different geographies will have to adapt different sets of solutions to get where they are. It will require a huge amount of capital. So our ability to draw the right capital and to be able to deliver the right returns is important. And therefore, it is also important for steel industry to actively collaborate with all the partners in the supply chain, because I don't think the steel industry by itself can make it happen. You need your customers to work with you. You need your supply chain partners to work with you. You need your raw material partners to work with you. You need the governments and the policy makers to work with you to make this work from a larger objective of making the planet sustainable and therefore helping the steel industry to get to a place where it can make it happen.
I look forward to seeing how this future does play out. But wow, what a conversation. Thank you so much for taking the time out to talk to us today. It has been an absolute pleasure. Thank you.
Thank you very much. It's been a pleasure for me too.
That is all we have got time for this episode. Of course, a massive thank you to our guests today, Helena, Fred and Rajesh, for joining us. I'm Fran Scott, and the Process Automation Podcast is a fresh air production for ABB. Follow now for free wherever you get your podcasts so you never miss an episode.